Hi everyone, I am Dr. Hang Ding, the instructor of the Computer Programming 1 course at IU South Bend. This video covers the first part of Java Basics lecture. My presentation about Java Basics consists of 8 sections. The first section is a simple Java program printing a line of text. The second section is more output methods. The third one is variables and primitive times. The fourth section is reading input. The fifth section is arithmetic operators and expression. The title of each slide in this presentation will also indicate which section it belongs to. The last three sections will be covered in the next video. This is the first Java program that you have run. It's a very simple program, only printing out a line of text that reads "Welcome to Java Programming." Now I'm going to explain every line of code in this program. The first two lines in the Welcome One Java program are commands because they start with double forward slash. The double forward slash indicates that everything in the same line afterward is a command. In a program source code, commands are used to document the program and improve its readability. When compiling the program, the compiler will ignore the commands in the program. A command that begins with a double forward slash, like those in the line 1 and line 2 of the Welcome One Java program, is an end of line command, which means that the command terminates at the end of the line on which it appears. An end of line command doesn't need to be placed in a separate line as in line 1 and line 2 of the Welcome One Java program. It can be placed at the end of any line of code, such as the comments in line 10 and line 11 of the Welcome One Java program, which are the last two lines of the Welcome One Java program. Another type of comments is multi-line comment, which can be spread over several lines as in this example. This type of command begins with a forward slash and an asterisk and ends with an asterisk and a forward slash. The sequence of a forward slash and an asterisk is the beginning delimiter, and the sequence of an asterisk followed immediately by a forward slash is the ending delimiter. All the text between the delimiters uh, is part of the command and is ignored by the compiler. In your program source code, you can add as many blank lines, space characters, and tabs as you want to make the program easier to read. For example, we add a blank line in line 3 of the Welcome One program. We also add one tab at the beginning of each line between a pair of an opening brace and the matching closing brace. Then the line between two nested pairs of braces begins with two tabs. Together, these characters are known as white space. White space is ignored by the compiler. Line 4 in the Welcome One program is actually the first line of code. It is the class declaration for the class Welcome One. Every Java program consists of at least one class. The class keyword introduces a class declaration and must be followed immediately by a class name. Of course, you need to insert at least one white space to separate the keyword and the class name. Keywords are reserved for use by Java and are always spelled with all lowercase letters. The Welcome One class is a public class because it is declared with the public keyword. You need to place the public keyword before the class keyword in the class declaration to make the class public. A public class must be placed in a file that has a file name the same as the class name and with the .java extension. So the source file containing the declaration of the class welcome one must be named welcome1.java. A class name is an identifier. In Java, an identifier is a series of characters that consist of letters, digits, underscores, and the dollar sign. It cannot contain any other characters. And uh, an identifier cannot begin with a digit and cannot contain spaces. Note that Java is case sensitive. So that means that uppercase letters and lowercase letters are distinct. So therefore, the identifier that start with little a and followed by one, and the identifier that starts with capital A and followed by one are different, um, but they are both valid identifiers. Note that you can use any valid identifier to name a class. However, by convention, a class name begins with a capital letter and capitalize the first letter of each word. For example, you may write sample class name, so there's no spaces, and you capitalize the initial of the word sample and the initial of the word class and the initial of the word name. Alright, so this one is just by convention. It's not a syntax rule, but we follow this convention so that when we have a long program and we have many type of identifiers, so when we look at this convention, so it will remind us that this is the name of a class instead of the name of a variable or the name of a function. The class name in a class declaration must be followed immediately by the class body, which begins with a left brace and ends with a right brace. For a good programming practice, you should indent the entire body of each class declaration, one level between the pair of braces that delimit the class body. This format emphasizes the class declaration structure and makes it easier to read. You can choose to use 2 to 4 spaces to form a level of indent. However, whatever you choose, you should use it consistently. The tab key may also be used to indent code. If you use an IDE to type your code, the IDE may indent a code for you. You can configure the IDE to specify the number of spaces inserted when you press a tab.
Okay, so when you type an opening left brace, immediately type the closing right brace. Then reposition the cursor between the braces and indent to begin typing the body. So for example, here I now can begin typing the body of the class welcome, which is public static void main. So this is the declaration of the main method. String. All right. So here I also have to type the opening left brace. Then I also type the closing left brace. The closing right brace right away. And then again, and I press enter and reposition the cursor between the braces and indent to begin typing the body within the braces. This practice helps prevent errors due to missing braces, and many IDEs insert the closing right brace for you when you type the opening left brace.
Within a class body, you can declare methods of the class. The class welcome one in our example has only one method, which is the main method. This line of code, which is in line 7 of the welcome one program, is the header of the main method declaration. The main method is the starting point of every Java application. A Java application can have more than one class, but one and only one class has the main method. The header of the main method declaration must be defined exactly as shown in this line. Otherwise, the Java virtual machine will not execute the application. A Java class declaration normally contains one or more methods. Each method perform a task and can return information when it completes its task. If the header of the method declaration contains the keyword void, such as in the main method, then it indicates that this method will not return any information. Each method declaration must have a body that follows the method header immediately. The body of a method is also enclosed in a pair of a left brace and a right brace. Within the braces, there are statements that instruct the computer to do an action. Most statements end with a semicolon. The body of the main method in our welcome one program has only one statement, which is in line 9. This statement displays the characters contained between the pair of double quote marks. Together, the double quote marks and the characters between them are a string, which is also known as a character string or a string literal. Note that white spaces in a string are not ignored by the compilers because they are part of the string. A string cannot span multiple lines of code, so you cannot break the string welcome to Java programming into multiple lines in the source code of welcome one. Similarly to the good programming practice with the body of a class, you should indent the entire body of each method declaration one level between the braces that define the body of the method. This makes the structure of the method stand out and makes the method declaration easier to read. Java allows a large statement to be split over many lines. However, you cannot split a statement in the middle of an identifier or string. Another good programming practice is to place only one statement per line in a program source code for readability. That is, a line of code should not contain code of two or more statements. This statement, which is the only statement in the main method of our Welcome One program, is to print out a line of text that reads Welcome to Java Programming! Exclamation point. This statement uses the object called system.out, which is known as the standard output object. This object allows a Java application to display information in the output window, which can be the same as the command window where the application executes. This statement is calling or invoking a method. In particular, when you write system.out.println followed by a parenthesis, then you invoke the println method of the system.out object. This method displays or prints a line of text in the output window. It will also position the output cursor at the beginning of the next line in the output window, so that the argument of the next output statement will be displayed from the beginning of the next line. The string inside the parentheses following the method name is the argument to the method println. Now we move to section 2 to explore more output methods. Recall that a string cannot span multiple lines of code. So if you want to print out a very long line of text with a single println statement, you could end up with a very long line of code that is hard to read. For example, if you use a single println statement to print out a line of text as long as this one, you may not be able to see the entire line of code in the editor window without scrolling. If you wrap your line of code, then it would break the string into multiple lines and cause a syntax error. One way to print a long line of text is to use multiple statements, where the last statement is println and all other statements are the print method of the system.out object. To demonstrate this approach, we modify our Welcome One program and save it as Welcome to program. The Welcome to program performs exactly the same task as the Welcome One program, that is to print out one line of text that reads Welcome to Java Programming. However, the Welcome to a program does this task with two statements instead of one. The first statement is to print out the string welcome to, which ends with a space but not a new line. After the print statement is executed, the output cursor is placed right at the end of the string it prints out, not at the beginning of the next line. When the next statement, which is println, is executed, it prints out the argument string from the cursor from the current position of the cursor, which is in the same line as the argument of the print statement. So the two statements of print and println in the welcome to program is equivalent to the println statement in the welcome one program. The new method we have learned is the print method of the system.out object. This print method also displays a string, like the println method. However, unlike the println method, the print method does not position the output cursor at the beginning of the next line in the output window. Therefore, the next character the program displays will appear immediately after the last character that print displays. Our next example, which is in the welcome 3 program, shows you how to print multiple lines of text with a single println statement. This program is the same as our welcome one program, except that we insert three new characters denoted by \n into the string argument of the println statement. The result of this program is four lines of text as shown here. The \n character that we inserted in this println statement is called the new line character. It tells the print and println methods of system.out to position the output cursor at the beginning of the next line in the output window. New line characters are white space characters. If you print two new line characters with a print statement, or print one new line character with a println statement, then it will print out a blank line in the output window. The backslash in the new line character is called an escape character. It indicates a special character. The backslash is combined with the next character to form an escape sequence. More specifically, an escape sequence is a sequence of a backslash followed by another character that has a specific meaning. There are about 8 escape sequences, excluding those with octogires. Here are the 5 common escape sequences. The first one is the new line character, which we already know. The second one, denoted as \t, is the horizontal tab. It will move the screen cursors to the next tab stop. The third one, which is \r, is the carriage return character. By the definition in the ASCII code, this character is supposed to position the screen cursor at the beginning of the current line, and it does not advance to the next line. However, the print and println methods of system.out object treat the two characters /n and /r the same. The fourth common escape sequence is double backslash. It is used to print a backslash character because if you type only one backslash in a string argument, then the system would think that it's the start of an escape sequence instead of the backslash you want to print out. The last one in the list here is the double quote. It is used to print a double quote character. For example, if you want to display this string with the double quotes, you will need to write backslash followed by a double quote instead of just the double quote within the string argument to the println or print methods. The complete list of escape sequences in Java SE 23 edition can be found at this webpage. Another method of the system.out object is printf, which displays formatted data. The F in the method name means formatted. This program welcome 4 demonstrates how to use the printf method. It calls the printf method only once to display 4 lines of text as shown in this output window. The second and the third line correspond to the second and the third argument of printf. Method printf takes multiple arguments where the arguments are placed in a comma-separated list. So in this call to the printf method, it takes 3 arguments. The first argument of the method of printf must be a format string, which may consist of fixed text and format specifiers. The fixed text will be output as is by print or println. For example, in this printf statement, the portion of the first argument highlighted in yellow is the fixed text. Each format specifier begins with a percent size and followed by a character that represents a data type. A format specifier is a placeholder for a value in the remaining arguments of the printf and specifies the type of data to output. For example, the format specifier %s is a placeholder for a string. There are 2 format specifier %s in this printf statement. The first %s specifier is the placeholder for the string in the second argument of printf. The second %s specifier is the placeholder for the third argument of printf. We will show more examples of using format specifiers in the next Java application. Now we move on to section 3 of Java Basics, which is about variable declarations and primitive types. As mentioned in the algorithm designs, most computer programs will use variables as a placeholder for data. In Java, variables must be declared with a name and a type before they can be used. A variable name enables the program to access the value of the variable in memory. The name can be any valid identifier. A variable type specifies what kind of information is stored in that location in memory. The syntax to declare a variable starts with the variable's type followed by the variable name. If you declare the variable without initialization, then you can end the declaration statement with a semicolon right after the variable name. If you declare and initialize a variable in the same statement, then you need to insert an equal sign after the name and followed by an initial value for the variable. Here are some examples of declaring variables to store integers. In this example, there are three variable declaration statements. They declare variables named number1, number2, and sum, respectively. All of these variables are declared to have type int. Time int holds integer values, that is, whole numbers such as -10 or 2 or 3500, etc. Note that the int values in a program may not contain commas. Several variables of the same type may be declared in one declaration with the variable names separated by commas. For example, we can declare the three variables number one, number two, and sum in this statement, which is equivalent to the three variable declaration statements above. All these three variables are declared without initialization. When declared without initialization in a method, a variable received no value. You will have to assign the variable a value later before using the variable. Let's look at other examples of variable declarations in a complete Java program. This is an addition program that displays the sum of two integer numbers. In the main method of this program, we declare variables number1 and number2 of time int and initialize them to the value 45 and 72 respectively. Then we declare variable sum, also of time int. After this declaration, variable sum does not have a value yet. In the next statement, we assign the variable sum to the value equal to the sum of the value in variable number 1 and the value in variable number 2. And finally, we display the value of sum in a formatted string. This is the output when the program executes. A variable doesn't have a value until it is initialized or assigned with a value. Then the value of a variable can be changed anytime during its lifetime. To change the value of a variable, you can use an assignment statement whose syntax starts with a variable name, then an equal sign, followed by an expression, and ends with a semicolon. The equal sign is called the assignment operator. It is a binary operator, meaning it has two operands. The left-hand side operand is always a single variable name. The right-hand side operand is an expression, which is any portion of a statement that has a value associated with it. The expression to the right of the assignment operator is always evaluated before the assignment is performed. The assignment statement sum equal number 1 plus number 2 calculates the sum of variables number 1 and number 2 and then assigns the result to the variable sum. The portion highlighted here, that is number 1 plus number 2, is an expression because it has a value associated with it. In our addition 0 program, we use this printf statement to display the value of sum in a formatted string. The format string in this printf statement has two format specifiers, %d and %n. The format specifier %d is a placeholder for an int value. The letter D in this specifier stands for decimal integer. So this %d specifier is the placeholder for the value of sum. The format specifier %n is a placeholder for a null character, which is the same as the \n character. Calculations can also be performed inside a printf statement as in this statement, which is the same as the printf statement above, but with the variable sum being replaced with the expression number 1 plus number 2. The parentheses around this expression are optional. Now I'm going to explain the memory concepts related to variables in a program. Every variable has a size and a value in memory. The size in bytes is determined by the variable's type. When a new value is placed into a variable, the new value replaces the previous value of the variable. If that variable has such a previous value before, then the previous value is lost. So this process is said to be destructive. For example, suppose we declare two variables x and y of time int, as in this statement. Then they both have the same size in the memory, and after this declaration statement, x and y may not have any value. Then we assign x to 10. This gives x the new value 10, and y still has no value after this assignment statement. Then we assign y to 2 plus x. Then y gets the new value of 12, and x value is not changed after this second assignment statement. Then we assign x to 99. This places the new value 99 into x, so its previous value of 10 is lost after this assignment statement. Besides int, there are other built-in data types for holding numbers. These types are also called primitive types. There are four primitive types holding integer values. The shortest type is byte, which has size of only 1 byte. It can hold integer values ranging from -2 to the 7 or -128 to 2 to the 7 minus 1 or 127. Because 1 byte has 8 bits, so it can hold 2 to the 8 different values, and we want those integer values to span evenly on both sides of 0. The short type has size of 2 bytes and can hold integer values from -2 to the 15 to 2 to the 15 minus 1. The int type has size of 4 bytes, so it can hold integer values from -2 to the 31 to 2 to the 31 minus 1, because 4 bytes has 32 bits. The longest type for integer is long, which has size of 8 bytes, so it can hold integer values from minus 2 to the 63 to 2 to the 63 minus 1 because 8 bytes has 64 bits. There are two primitive types holding real numbers with floating point values. The short one is a float, which has 4 bytes, and it has the value approximately in this range. The long one is double, which has 8 bytes. Note that since you cannot use commas in numeric values in your source code, you can use underscores to make numeric literal values more readable. For example, to write 1 million, um, you cannot write the comma like this in the source code, so you can replace these two commas with the underscores in your source code. There are also two other primitive types, namely Boolean and char. The Boolean type has size of 1 byte and can hold only two values, true or false. These values are called Boolean values. The type char has size of 2 bytes and can hold any ISO Unicode characters as value. The Unicode characters can be represented by the octal escape sequences, which start with \u. Primitive types in Java are considered portable across all platforms that support Java, meaning that a Java program using primitive data types can run only on any system with a compatible Java runtime environment without needing to modify or accommodate different operating system or architectures. Now I'm going to show you more examples of variable declarations in Java. In these examples, we will declare the following 5 variables in a program that simulates a simple calculator. We will also declare a variable named input input valid that indicates whether all inputs are valid. But first, I'd like you to practice with these examples. You can pause the video now and write out the variable declarations for these examples by yourself. After you have written down your answers, you can continue the video to see a solution.
Here are how you declare these 5 variables in the calculator program. Recall that variables num1 and num2 store the two operands of the math operation that the program needs to do. We can assume that those two operands are of the double value. And the variable result will store the result of the math operation. So it must have a double value as well. Therefore, we can declare these these 3 variables in a single statement. Double num1, comma, num2, comma, result, semicolon. The math of variable stores the math operator, which is either a plus or a minus or an asterisk for multiplication or a forward slash for division. In other words, it stores only a single character. So its data type is char, and we declare it as char math of semicolon. The variable answer stores the user response to the question, do you want to continue? And we can also let the user type a character Y for yes and a character N for no. So variable answer is also of type char. Therefore, we can add it to the same declaration with the math of a variable. So we add and we need to separate them with a comma. So we type answer uh, between the comma and the semicolon in this declaration for the math of variable. The variable input valid should have only two possible values. One indicates that all inputs are valid, and one indicates that not all inputs are valid. In other words, it has Boolean values and therefore must be declared with a Boolean type, with the Boolean type. So we type Boolean and then the variable name, input valid, and then end with a semicolon. So this is the solution to the examples in the previous slides.
When you declare variables in your program, I'd like you to follow these two good programming practices. First, choose meaningful variables name because it helps a program self-documenting. That means one can understand the program simply by reading it rather than by reading associated documentation or creating and viewing an excessive number of comments. The second good programming practice is to name variables by convention, in which variable name identifiers begin with a lowercase letter, and every word in the name after the first word begins with a capital letter. For example, variable name identifier first number starts its second word number with a capital N. This naming convention is known as camel case because the uppercase letter stand out like a camel's humps. Now we start section 4 of Java Basic, which is about reading input. Most programs will need input entered by the users. Java's predefined class scanner enables a program to read input from different sources, such as from the keyboard or from a file. But in order to use the predefined class scanner, you would need to import it with the following import statement. So this statement starts with the keyword import, followed by the class name and the package. So this statement indicates that the program uses a predefined class scanner from the package named java.util. Util is short for utility. An import declaration like this one helps the compiler locate a predefined class used in a Java program. Let's look at an example in another additional program that inputs two numbers and then displays their sum. This program, we call it addition, works similarly to the addition zero program in the previous example, except that the two numbers that will be added will have the values entered by the user instead of a predefined value defined in the program. So in the main methods of this program, we also declare three variables, number one, number two, and the variable sum. But here we don't have to initialize number one and number two. And then we will have the user enter the value and store it to number one. And so in order to do that, we have to use the scanner class, and therefore we have to import that scanner class before the declaration of the class addition. So then the line 18 and line 21 here are the codes that will read the numbers from the user. And I will explain these slides later. And so after we get the values for number one and number two from the users, so now we can calculate the sum and by setting it equal to the sum of number one and number two, and then print out the value of sum in a formatted string as in the addition zero program. And so when you run this program, so it also print out the string, enter the first integer, and the user will enter the number 45, okay, and then hit enter. Then it show enter second integer. Then the user enter the number 22 and hit enter. Then it display the sum is 101, 117. To use scanner, you first need to create a scanner object and specify the source of the data associated with it. A scanner object translates bytes of data that the user enters into types that can be used in a program. In our addition program, we create a scanner object by this variable declaration statement. In this statement, input is the variable name and scanner is its data type. The new keyword in the right-hand side expression of this equal sign creates an object. The expression after new is the type of object being created. In this case, it is a scanner object. The variable input is then initialized with the scanner object created. This scanner object is associated with the standard input object, which is specified by system.in. The standard input object enables applications to read bytes of data entered by the user from the keyboard. Before your program reads input from the user, it should prompt the user for input. This practice is to make the user interface of your program more user-friendly. A prompt is an output statement that directs the user to take a specific action. For example, before reading number one from the user, the addition program executes this prompt, which displays the message that tells the user to enter the first integer. By the way, so far we have used several statements and expressions that start with system followed by a dot. Those statements and expressions use the predefined class as system, which is a part of package java.lang. So technically, we would have to import the class java.lang.system in our source code, but we don't have to. The reason is that the package java.lang is imported in every Java program by default, so we don't have to include an import statement for any class in this package. Classes in java.lang are the only ones in Java API that do not require an import declaration. Now I'm going to explain the line of code that actually obtains an int value as input from the user. Assume that a variable input has been declared and initialized to a scanner object associated with the standard input object as in this statement. Then we can call the method nextInt of the scanner object by using the expression input dot nextInt and then open parenthesis and close a parenthesis. So this expression is the call to the method nextInt of the scanner object that is stored in the variable input. So this assignment statement obtains an integer from the user at the keyboard. When it executes, the program waits for the user to type the number and press the Enter key to submit the number to the program. The result of the call to the nextInt method is placed in the variable number 1 by using the assignment operator. You can also obtain a double value as input by using scanner. First, you need to have a scanner object created. You can use the same scanner object that has been created and used to obtain other inputs in the program. For example, suppose you have created a scanner object from this statement and stored it in the variable input. You may have used variable input to obtain an integer from the user. Now you can use it again to obtain a double value from the user by calling the nextDouble method of a scanner. The expression input dot nextDouble open parenthesis close parenthesis is a call to the nextDouble method of the scanner object stored in the variable input. When it executes, it will wait for the user to enter a double number and hit enter. Then the result of this call will be assigned to variable D by the assignment operator. Here, variable D must be declared as of type double because it receives a double value. For a user-friendly user interface, you may want to prompt the user to enter a double value before calling the nextDouble method. For more examples of obtaining a double value as input, you can try these live examples provided in the textbook. I also posted the link to the first live example on our Canvas module. Hooray! We have covered 4 sections of Java basics. Now we move on to section 5, which is about arithmetic operators and arithmetic expressions. This is the last section of Java basics covered in this video. There are five arithmetic operators in Java: addition, subtraction, multiplication, division, and remainder. All of them are binary operators because uh, each operates on two operands. The addition and subtraction are indicated by the plus sign and the minus sign as in algebraic expressions. The multiplication is indicated by the asterisk. The division is indicated by the forward slash. The percent sign is the remainder operator. Recall that in mathematics, when you take an integer divided by another integer, you get an integer quotient and a remainder. However, in Java, when you write the expression x forward slash y, where both x and y are integers, then the result of this expression is an integer quotient of the division. Any fractional part in the integer division is simply truncated or discarded. No rounding occurs. The remainder operator, which is the percent size, yields the remainder after division. So to get the remainder of x divided by y, you have to write x percent y.
This is an example that demonstrates the integer division in Java. Here we declare two integer variables, x and y, and assign value 11 to x and value 5 to y. So if you take x divided by y in algebra, you would get 2.5. In this Java program, we print out the value of x slash y or x divided by y using this printf statement, which also prints out the value of x and y in this format. When we run this program, it prints out the value of 2 for the expression x forward slash y. It also prints out the value of the expression x percent y in the last printf statement. So the remainder of 11 divided by 5 is 1. Note that in this last printf statement, we also wanted to print out the expression x percent y, where x and y are replaced with their values. But to print out the percent size with the printf method, we need to escape the percent sign with another one. Because the percent size within a format string is used to indicate a format specifier. If you write a percent size alone like this, it would cause a syntax error.
Arithmetic expressions in Java must be written in straight line form. That means that expressions such as a divided by b must be written as a forward slash b so that all constants, variables, and operators appear in a straight line. In algebra, it's acceptable to place redundant parentheses in an expression to make the expression clearer. So you can also use parentheses in Java to group terms in expression in the same manner as in algebraic expressions. If an expression contains nested parentheses such as in this expression, Then the expression in the innermost set of parentheses, in this case is the one around a plus b, is evaluated first. In an arithmetic expression, you can combine many arithmetic operators where the result of one operator can become an operand of another operator. In that case, the system needs to follow the rules of operator precedence to decide which operator is evaluated first, which one is evaluated next, and so on. Here are the rules of precedence of the operators we have learned so far, which include arithmetic operators and the assignment operator. Multiplication, division, and the remainder operators are applied first. If an expression contains several such operations, they are applied from left to right. Multiplication, division, and remainder operators have the same level of precedence. Addition and subtraction operators are applied next. If an expression contains several such operations, the operators are applied from left to right. Addition and subtraction operators have the same level of precedence. When we say that the operators are applied from left to right, we are referring to their associativity. Some operators, such as the assignment operator, associate from right to left. That means that we evaluate the right side of the operator before the left side of the operator. This is an example of expression evaluation where the rules of precedence are applied. In this example, we try to evaluate this expression. Okay, so in this expression, we have three multiplications and two addition. Okay, and they are combined in different ways. So here, by the rule, the multiplications are applied first, and it is applied from left to right. So we need to apply the first multiplication here, the leftmost multiplication here, which is 2 multiplied by 5, and the result is 10. Right? So here now we replace the 10 for this expression. And we also apply the next multiplication, which is between 10 and 5. So that is this one. And so this results in 50. Right? So we can replace a 50 for this part of the expression. Right? And so here now we would have addition, multiplication, and the addition, okay, and without parentheses. And by the first precedence rule, application must be applied before addition. So here we have to apply this multiplication before the first addition. So we apply 3 multiplied by 5, which is 15. So we replace 3 multiplied by 5 with the 15 in the evaluation path. Well, so now we have just two remaining additions to evaluate, and we also evaluate from left to right. So the leftmost addition is applied first. So we take 50 plus 15. The result is 65, and we replace 50 plus 15 with 65 before evaluating the last one. Okay, so now this is the last addition. So we just take 65 plus 7, which is 72. So the result of the original expression is 72. Thank you for watching. I hope you understand what I explained in the video. If you have any questions, please feel free to email me. Thank you.